Hello. You really don't need to watch all of this video. Just skip to the bit you're interested in, because in this video I'm going to be talking about how to find the area and the perimeter of a rectangle, the area and the perimeter of a triangle. Do you know this shape? It's a parallelogram, so we're going to find out how to work out the area and the perimeter of parallelograms. What's this? It's a trapezium. The top is parallel to the bottom, or in this way, this side is parallel to this side, and this shape is called a trapezium. So that'll be a bit later in the video. Then we'll be flying this shape, a kite, where the two sides next to each other are the same length, and the two sides down here next to each other are the same length. And then we'll be looking at what happens when maybe you put some shapes together to make a composite shape, and how you would work out the area and maybe the perimeter of a composite shape. And then finally, we'll have a little bit of fun with some puzzles. So, let's begin. Let's begin with the rectangle. Okay, here I've drawn some rectangles on squared paper. So let's start with a little yellow one in the top left. It covers 6 of the squares of the grid. Now, if each of the grid squares is 1 centimetre by 1 centimetre, or 1 square centimetre, that yellow rectangle has an area of 6 square centimetres. Then below that, the green one, it covers 1, 2, 3, 4, 5, 6, 7, 8 squares, so it has an area of 8 square centimetres. And so does the other green one. Even though it's the other way round, it has got 2 columns and 4 rows, whereas the first green rectangle had 2 rows and 4 columns. We can use that column and rows method to quickly work out the area of the blue one. If it's got 2 rows and 1, 2, 3, 4, 5, 6 columns, 2 times 6 is 12. So if you counted all those squares, you would find the area would be 12 square centimetres. And that's really useful when you get a big one, such as the red one on the right. Instead of counting every single square, I'll just count how many columns there are. That's going from top to bottom. How many? 1, 2, 3, 4, 5, 6. And then how many rows are there? They go from left to right, the rows. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 rows and 6 columns. So 8 times 6 is 48. So the area of that must be 48 square units or square centimetres. This one here, again, we could work it out with the squares, but usually you don't have squares in rectangles. You would just have something like this, where the measurement, the length, and the width are given to you. So the length is 12, the width is 6. You multiply those two together, that's the rows and the columns. 12 times 6 is 72, and the units would be centimetres squared. So the area of that is 72 centimetres squared. This one, same rule, length times width, 11 times 4, that's 44 centimetres squared. So that is how you find the area of a rectangle. You multiply the width by the length. And that's a formula that we have for the area of a rectangle. The length times the width, or the width times the length. Of course, it doesn't matter which way round you do multiplication. You'll always get the same answer. But some people call the long measurement the base, or the one at the bottom the base, and the other one the height, the one that goes up the height. So you do the same thing, you multiply them together. So you could say the formula for the rectangle is the base times the height, or the height times the base. It doesn't really matter. As long as you multiply those two numbers together, that will give you the area. So that's the rectangles, which, if you really want to impress your teacher, you could call them equiangular quadrilaterals, because they're four-sided shapes that have equal angles. They're all 90 degrees. And did you know that even squares are rectangles, but they're special rectangles because all of their sides are the same length? In fact, if you wanted to have a rectangle that definitely wasn't a square, you could call it an oblong, because oblongs are rectangles where all four sides aren't the same length. But for now, let's just call them all rectangles. Right, I've drawn two rectangles on this squared paper, but I haven't drawn them to scale. So the idea is not to count the squares to find the area, but the idea is to use the length and the width and that formula to work out the area of the rectangles. So the first rectangle is 9 centimeters long, that's the length, and it's 4 centimeters wide. So I need to do 9 times 4, which is 36. So the area of that first rectangle is 36. And the units are centimeters squared. That's how many square centimeters are covered by that blue rectangle. So the green one, again, it's not drawn to scale, so you can't count the squares, but look at the measurements. In fact, the measurements of all the sides have been given. But to work out the area, we only need the length and the width, so don't be confused by the extra measurements. So the length is 3 centimeters, the width is 4 centimeters. It could be either way around, of course. So the calculation that we have to do is 3 times 4, which is equal to 12. So the area is 12 centimeters squared. Now, we can also work out the perimeter of this green rectangle. We just add up the lengths of all of the four sides. 3 plus 4 plus 3 plus 4. So it's 3 plus 4 plus 3 plus 4, which is equal to 14. So the perimeter is 14 centimeters. It's a length. It's a length that goes all the way around the rectangle. Now the blue rectangle only has two measurements, the 4 and the 9. But because it's a rectangle, we can see what figure should go here. It's going to be 4, and what figure should be here. That's going to be 9. So, in a similar way, the calculation we have to do is 9 plus 4 plus 9 plus 4. So that's equal to 26. So the perimeter is 26 centimeters for the blue rectangle. So there are our answers. We've worked out the area and the perimeter of the blue rectangle, and also the area and the perimeter of the green rectangle. Now, rectangles can be any way round. And this one, even though it's an odd angle, is still a rectangle. And the formula is still the length times the width, even though the width has been written down twice, just to confuse you. So nevertheless, we'll stick to our formula, and the calculation we need to do is 6.2 multiplied by 2.9. And that, if you use a calculator to help you, or you can do it by pen and paper, up to you, is 17.98. Now, sometimes you might be asked to give your answer to one decimal place, or sometimes to 3 significant figures. But here I'm going to give the answer in full. The answer is 17.98, and that is the area. So the area is 17.98 centimeters squared. Now I can also calculate the perimeter. And for that I have to add all the sides together. So that will be 2.9 plus 6.2 plus 2.9 plus, and even though the other length isn't written down on the diagram right there, we know that it should be 6.2, the same as the side opposite. So let's see, we need to add these all together. We could do it in pairs. 2.9 plus 6.2 is 9.1. So I've just simplified it there a little bit. And now that's easy for me to do in my head. Add those two together, and that will be 18.2. So the perimeter is 18.2 centimeters. Now we get to triangles. How do we find the area of a triangle? Well, you can imagine a triangle fitting nicely inside a rectangle, and you know how to find the area of a rectangle. It's the base multiplied by the height. But because that triangle only takes up half of the area of the rectangle, our formula has got a half in it. It's a half the base times the height. And the height of the triangle must be measured at right angles or perpendicular to the base. So the full formula is a half the base times the perpendicular height. And that doesn't matter which way around the triangle is. You must make sure that the two numbers that you're multiplying and then halving are at 90 degrees to each other. So if you choose that length as the base, if you tip your head around to make that sort of the base, then that isn't the height because it's not at right angles to the base. The height would have to be measured and you'd have to have a right angle right there, and that would be the height that you would use to work out the area of that triangle. Let's use the formula, a half base times height, to work out the area of this triangle. So the calculation I need to do is a half, don't forget the half, it's a half of 5 times 8, which is equal to a half of 40. 5 times 8 is 40, which is equal to 20. So the area of this triangle is 20 centimeters squared. Now, what we've done is we've multiplied the base by the height and then we've halved the answer. But what I could have done is halved either the base or the height before I do the multiplication. So another way of doing this would have been the base times half of the height, and that would still have given me the answer 20. So sometimes it makes the maths a little easier if the numbers are lower, so you can halve one of the numbers, just one of them, before you do the multiplication, rather than halving the product. Now, even though we say base times height, the base doesn't necessarily have to be horizontal. So in this case, you can see that the 8 centimeters represents the base of the triangle, and then we have the 10 centimeter representing the height. And the key thing is that the height must be perpendicular to the base. That means it should make right angles so I can put a little square there to represent 90 degrees. That should be 90 degrees so that we can see that the height is perpendicular to the base. Now I can do the calculation. A half, don't forget the half, of 8 times 10. So I could multiply 8 by 10 and then halve it, or I could halve one of the numbers. I'll halve the 8, and then I get the answer 40. So the area of this green triangle is 40 centimeters squared. Now here's a right angle triangle, and we've got 3 measurements, the 3 sides. We've got the 4, the 3 and the 5. Which ones do we use? Well, remember the height and the base have to be perpendicular, and as we already have a right angle in this diagram, I'm going to choose the 3 as being the height because that is perpendicular to the 4, which is going to be the base. So the area is going to be a half of 4 times 3. 4 times 3 is 12, half it is 6. So the area is 6 centimeters squared. Now here's an obtuse angle triangle, and the dotted lines show the perpendicular height outside the triangle. So it's the highest point of the triangle over the base, but we still need that right angle there to make sure it's at right angles or perpendicular to the base. So the calculation I need to do this time is a half, as always, of 3.1 is the base, multiplied by the height, which is 2.2. So you could do that by long decimal multiplication and then halve it, or you could work it out on the calculator, and I've used the calculator to get 3.41 as my answer. So the area is 3.41, and the units for area in this case, oh, they're not centimeters squared, they're meters squared, because the measurements are given in meters. The next shape is a parallelogram. It's got 4 sides, and the opposite sides are parallel to each other. So let's have a look at how we would find the area. I think that if you chopped that bit off the left and added it onto the right, it would make a perfect rectangle, and we already know the formula for the rectangle. It's the base times the height. So we can use the rectangle formula. It's exactly the same for a parallelogram because of that little trick of chopping off a triangle on the left and adding it to the right, turning it into a rectangle. The area is the base multiplied by the perpendicular height. Remember, it must be at right angles. It doesn't matter which way round the parallelogram is. The height must always be at right angles to the base. You multiply those two numbers together, and that gives you the area of the parallelogram. So here we have a parallelogram. Its base is 12 and its height is 10. So it's very simple to work out the area. We just need to multiply 12 by 10, which is a nice easy calculation, 120. So the area is 120 centimeters squared. Simple as that. And here is another parallelogram. This time can you see that the perpendicular height is outside the shape, but there is a right angle marked right there to show that the height is perpendicular to the extended line of the base. So that means we can use our formula, and this time we have to do 7 times 8, which is 56, so the area is 56 centimeters squared. Now here is another parallelogram, but can you see that in this case the height is marked perpendicular to the right hand side? So we have to consider the right hand side as our base. So there are other measurements on here that we don't need. We don't need the 7 centimeters, that's sort of a distractor, but we do need the 9 for the base and the 6 for the height. So let's do the calculation. It's just 6 times 9, and 6 times 9 is 54, so the area is 54 centimeters squared. Now, because of all these measurements, we can also work out the perimeter. That's what you get when you add all of the sides together. And then I'm going to do it 2 at a time. 7 plus 9 is 16, so it's 16 plus 16, which is equal to 32. So the perimeter is 32, and that will be in centimeters because it's a length. Now this one is here to confuse you. That 6 centimeters right there is the length of that dotted line, which is not the height, because can you see it's sloping to the left and it's not perpendicular to the base? So the line that is perpendicular is the 5 centimeters. And I can tell you that that sloping 6 centimeters is actually parallel to the sides. So I could write down 6 centimeters for those two parallel sides. So let's get back to business. We now know it's the base, which is 6, multiplied by the height, the perpendicular height, which is the 5. So I multiply 6 by 5 and I get 30, so the area is 30 centimeters squared. And I can underline that. But in this case there's another measurement I can put on. I know that is 4 centimeters as well, because if it's a parallelogram, the opposite sides are parallel and equal. So now I know all of the lengths of the sides. So what I have to do is add them all together. 4 plus 6 plus 4 plus 6. Add them together in pairs. 10 plus 10 is 20. So the perimeter is 20 centimeters. The trapezium. It's a 4-sided shape, and one pair of opposite sides are parallel. So in the yellow trapezium, it's the top and the bottom. In the blue trapezium, it's the left and the right. So how do we find the area of a trapezium? Is it like a rectangle in any way? Well, we have a height for the yellow trapezium, but the width at the top is quite a short length, and the width at the bottom is quite a long length. So what we should do is actually find the average or the mean of the short and the long lengths. That gives us the average width, and then we can multiply that by the distance between those two parallel lines, and that should give us the area. So the formula for the area of a trapezium is the average of the parallel sides multiplied by the distance between them. And that would work in the blue trapezium as well. And sometimes, if you're doing an exam, you might be given the formula in this format where they use letters instead of words. So in this case, the top or the short length is B, and the side parallel to that, which is longer, is A. So in the formula, we're finding the average of A and B by adding them together and dividing by 2, and then multiply that by the height or the distance between those parallel lines. So I'm going to use that formula that the area is the average of the top and the bottom, the parallel sides in this case, multiplied by the height. So I'm going to do 8 plus 12, add them together and then divide by 2. That's how you work out average. And that's going to be multiplied by the 14. So I can see that 8 plus 12 is 20. Divide that by 2, it's 10. So that'll give me 10 times 14. So the area is 140 centimeters squared. I don't have enough information on this diagram to work out the perimeter, but if I knew those two sloping sides, and they're not necessarily the same length, then I could work out the perimeter. So let's say, for example, that this side on the right was 15 centimeters and the side on the left was 16 centimeters. Then to work out the perimeter, I would have to do 12 add 16 add 8 add 15. Those are the four sides, so the perimeter, and that will be in centimeters. Here is another trapezium with the height shown outside the shape. So what I can do is go straight to my formula and work out the average of the parallel sides. That's 3 plus 9 divided by 2. That works out the average of 3 and 9. And then that's going to be multiplied by the height, which is 10. So 3 plus 9 is 12. Half that is 6. Multiply it by 10 is 60. So the area is 60 centimeters squared. And the perimeter is 9 plus 11 plus 3 plus 12. So the perimeter is 35 centimeters. Now, this is not always recognized as being a trapezium, but in fact it does have one pair of parallel sides, the left and the right. So it is a trapezium, and we can use that same formula. So we have to work out the average of the parallel sides, 5.5 add 8.5, all divided by 2, and then multiply that by the height, or the perpendicular distance between those parallel sides is the 4 centimeters. I can see that from the right angles here and here. So I need to multiply that by 4. So let's see, 5.5 plus 8.5 is 14. Divide that by 2, that's 7. Multiply the 7 by the 4, and that will give me 28. So the area is 28 centimeters squared. Now the perimeter is all of these added together. 4 plus 8.5 plus 5 plus 5.5. I'll add together the whole numbers first. 4 and 5 are 9. Then I'll add together 9 and 5, which is rounding up the 8.5 and rounding down the 5.5. So that's 9 and 5 is 14. So that will give me 23. And that will be in centimetres because it's a length. There we go. Time for you to have a go. Now we come to the kite. This is a four-sided shape where adjacent sides are the same length. So in the yellow kite, the two sides at the top are the same length and the two sides at the bottom are the same length. Now, that will also fit into a rectangle that we know how to find the area of. If we have the height and the width of the rectangle in this case, can you see that those blue dotted lines split up the rectangle into 4 pieces, and each of those pieces, the yellow part of the kite takes up half the area. So we can say that the kite has an area of half the rectangle that encloses it, like that. So the formula is going to be half the width times the height, and that works whichever way round the kite is, as long as you have the right measurements. The width is between two opposite vertices and the height is between the other two opposite vertices. Multiply those two together to get the area, which is half of the width times the length. So it's a half of 30 times 70. So that's a half of 3 7s are 21, and they both have a factor of 10 in them, so that will give us 2,100, and then half of 2,100 is 1,050. So the area is 1,050 meters squared. Wow, that is one big kite. Imagine the size of that. I bet that would fly well. Now, we don't have enough information to work out the perimeter, although we could do it if we used advanced trigonometry, but as far as this exercise is concerned, no, we don't have enough information to find the perimeter. So here is another kite. Let's go straight into the formula. We know that it's going to be half of 6 multiplied by 8.4. So that is going to give me 50.4, and half of 50.4 is 25.2. So the area is 25.2. Because it's area, in this case it will be millimeters squared. And finally, let's have a look at this with so many numbers on. Well, a lot of the numbers are just to distract you from working out the area, but they'll be needed for the perimeter later on. So here we go. We have got the width is 7.07, so we want a half of 7.07 multiplied by the height of the kite, which is the other dotted line. That will be 13.1. So that gives me 92.617. So dividing that by 2, and then on this occasion I'm going to round off my answer to 3 significant figures. So I get 46.3, and the area, of course, will be meters squared. So that is my answer. On this occasion, we can work out the perimeter as well. So that will be 11 plus 5 plus 5 plus 11. So we'll add the 11 and the 5 together to get 16, and then double it to get 32. So the perimeter is 32, And that will be in meters because it's a length. It's the distance all the way around. Okay, over to you. Composite shapes or compound shapes are made up where some of the shapes that you know how to find the area of now are put together to make a more complex shape. So for example, something like this. How on earth would you find the area of that? Simple. You split it up into shapes that you know how to find the area. So let's have a look at a simpler one. Can you see that you can split up this shape into two rectangles by adding a line? Pause the video here and see if you can work out how to do that, and then find the area of the rectangles and add them together. Well, I decided to put my line here, but you might have put a vertical line in. That still will work and give the same answer. So I've got a rectangle at the top, which is 2 times 11, which is 22 meters squared, and a rectangle at the bottom, which is 5 by 8, which is 40 meters squared, which I can then add together to get a total area of 62 square meters. Here's another shape. How do you think you'd find the area of this? Pause the video and have a go. Well, I can see a parallelogram at the top, a parallelogram at the bottom, both the same size, and a big rectangle in the middle. So I'll work out the areas of the shapes. I've got the 4 times 18, that's the area of the rectangle, and because there are 2 parallelograms, I've got 2 lots of 2 times 4, which gives me an area for that compound shape of 88 square centimeters. And finally, some area and perimeter puzzles, just to make you think a little bit more. So here's a nice easy one to start with. The perimeter of this triangle is 23, whatever the units are. We have to find what that letter C stands for. Okay, pause the video, have a go at that yourself, or come back here for the solution, which I'm going to show right now. So what I would do is I would make up an equation and say that if you add these 3 lengths together, you'll get the perimeter, 23. So I can see that collecting all those C's, there are 3 C's on the left, and there's an extra 8 on the left, and that must be equal to 23, so I'll subtract 8 from both sides. 3C is equal to 15, so C must be equal to 5. Very straightforward. And now, we have to find the area of the rectangle. Can you see that pink rectangle? That's 2 centimeters wide, but we don't know how long it is. Okay, have a go at this yourself. Pause the video and then come back here if you'd like to see how I tackle this. Okay, well what I do is look at that triangle on the right. I can see its area is 21 and I can see its base is 7. So how high must it be? What's the height? Well, I think it must be 6 because 6 times 7 is 42, and if you halve 42 you'll get 21, which is the area of that triangle. So if the height of the whole of this composite shape is 6 centimeters, and that red triangle isn't quite as tall as 6 because there's the 2 at the bottom for the rectangle. So I think the red triangle must be 4 centimeters high. I took that 2 centimeters from the 6 centimeters. Okay, well if it's 4 centimeters high and its area is 16, I think I can figure out what its base is. Its base must be 8, and I can write that down underneath the rectangle. Because 4 times 8 is 32, and then if you halve it, you'll get 16, the area of the red triangle. So now I know that pink rectangle has a width of 2, a length of 8. It must have an area of 16 square centimeters. We need to work out the yellow area, the area of the yellow rectangle. Pause the video, have a go, come back here when you'd like to compare your method with mine. Well, I can see that a yellow rectangle has got a width of 4 centimeters from the diagram, but I don't know its length. But I do know that that red rectangle has an area of 20, so its width must be 5, because 5 times 4 is 20. So if the red is of width 5 centimeters, so must that light blue one. That must be 5 centimeter width as well, and because its area is 25, if I divide 25 by 5, I'll get 5 for the length of that. Okay, so that purple area now must also have that dimension as being 5 centimeters, and if its area is 35, then I guess that must be a 7, because 7 times 5 is 35. So that tells us the length of the yellow rectangle, it must be 7, so the area is 7 times 4, 28 square centimeters. A rectangle has an area of 24 square centimeters and a perimeter of 20 centimeters. Find the length and width of this rectangle. Well, I've actually chosen some easy numbers for this so that you can do this in a number of ways. I mean, you could actually look at all the lengths and widths of rectangles that would give you 24 centimeters and maybe write them out in a table like that. But we actually don't know that the length and width are whole numbers. We don't know that they're integers. So they could be decimals, and in that case, drawing up a table of all possibilities would be impossible, because there would be an infinite number of possibilities. But for this one with the easy numbers, you could do it like that, and then work out which of those would give a perimeter of 20. But I suppose the more substantial method is to use algebra. So let the length of the rectangle be L and the width be W. And then we know that if you multiply them together, LW, you get 24. And if you add them together and double it, you'll get the perimeter. So there I've got 2 equations. So from the second equation, I can divide both sides by 2 and get L plus W equals 10, or rearranging that to give L is 10 minus W. Then I'll substitute that value for, or that expression for L into the first area equation. So I've replaced the L by 10 minus W. And now I've got an equation that only contains one unknown. So if I multiply out the brackets and then maybe rearrange that, you may recognize that this is a quadratic equation, and you may know how to solve a quadratic equation by factorizing or using the formula or completing the square. So if I solve this quadratic, I get W equals 4 or W equals 6. And because the width and the length are interchangeable, there's nothing to say the length has to be longer than the width. I'm going to say that one solution is the width is 4 and the length is 6. Okay, now it's your turn to have a go at the online exercise. Don't forget to press the check button regularly as you're working through the questions to see if you're getting them right. And if you make a mistake, have another think and correct your answer, and then press that check button again. Don't forget to claim your trophy when you've got to the end. And there are lots more activities on the Trapezium website for you to have a go at to improve your mathematics, and you can claim hundreds of trophies. So, what are you waiting for? Get going! Bye!
You can find Trapezium Mathematics at www.trapezium.org, where you're welcome to use all of the activities absolutely free. Or jump in with both feet and become a Trapezium subscriber.